Hello everyone, I am Sudarshan, Assistant Professor, Department of Biomedical Engineering from Sri Shanmuga College of Engineering and Technology. Now we are going to see about IoT. So the next topic is what are all the components which are present in IoT and their functions. Now the basic components of IoT are data collection, data transmission, data processing, and then user interface. So initially what happens is data collection. So data collection meaning you will use some component to collect data from a real-time environment or a physical environment. So once you collect those data, you will transfer those data or transmit those data using some form of connectivity such as Bluetooth or Wi-Fi. Using some form of network, you will transmit those data to a cloud. So once the cloud platform receives those data, the raw data will be processed so that it could be turned into some kind of meaningful information. So once those meaningful information has been converted, you, meaning a user such as yourself, by using an application or a web page, we can look at what are all the data which has been collected. Now we will look into this in detail. Okay. So initially data collection. So how do you collect data? In IoTs, the major data collection points are done by sensors. So by employing sensors in a physical environment, we can collect all the data from the, if there is any change in the physical environment, these data will record those changes. So all these changes can be collected as a data and then we can process those data. So based upon our own applications, we will use different types of sensors such as temperature sensor or humidity sensor, light sensor or chemical composition sensor, whatever the sensor. There are lots of types of sensors, but based upon your own applications you will be using a particular sensor. So so how does it work? A sensor initially will detect some kind of changes in property. Okay, once it detects those changes, it will convert all the changes into an electrical signal, and those electrical signal will be sent to a microcontroller. This microcontroller will receive those signals and then it will convert all the signals into a digital data which will be sent to your cloud. So all the data which are collected by your sensors are analog data. So let me give you an example. Let's just say um, you have an agriculture applications. So you are going to employ a moisture sensor. So what does moisture sensor do? It records change in moisture value of your agriculture field. So whenever the temperature rises, the soil moisture automatically decreases. Let's just say during the daytime, the moisture content of the soil will decrease gradually. Okay, so when these changes occurs, your sensor will detect these changes and then records it. So this will be sent to a cloud storage. Now transmission. How all these data which were collected before sent to a cloud by using some kind of connectivity. So for example, you will be using Wi-Fi or Bluetooth for short range communications. For long range communications, you will use LoRaWAN, which meaning long range wide area network, and then NB-IoT, which is narrow band IoT. So all these data will need some kind of connectivity to transfer those data to your cloud. So we will take an example. So you have an Wi-Fi. Okay, you have a web page or an application. Now what happens is when you have we will take the previous example, which is a soil sensor. So the soil moisture sensor will record the changes in your soil. Then by connecting it to the Wi-Fi, it will convert all those signals into a digital signal. And then those digital signals will be sent to your web page by using connectivity. Okay, so this is actually one of the important part of your IoT, because all the data which has been collected from a physical environment will can only be transferred using some kind of connectivity to your cloud. If there is no connectivity, all the data which was collected before cannot be transferred anywhere, so that you cannot have in data to process as well as data to look at. Okay, so based upon your own applications, you can use whatever connectivity you want to. So for example, if I'm using an health watch, you have a wearable device, right? You will have all the data which will be recorded by your watch nowadays. So the watch will collect all the physical information such as your body temperature, your calories burnt, number of steps you have walked, you have covered. This will be transferred to your phone. How? By using Bluetooth. Since you will be having your phone and your wearable device in a short range, we will be going for Bluetooth. Okay, so if a sensor is in a remote place, we will be using some other application. So connectivity and data transmission is a vital part in your IoT. So next what happens? All these data which was collected and then transferred can now be processed. So imagine, so previously you have collected some data using sensors, then you have transferred those data to your cloud using some kind of connectivity. Now all the raw data is in your cloud, but you cannot use those data because you want exact proper value of those data. So each and every data can be processed, okay, at a different stage for different purposes. Now we are going to look at what are all the stages of data processing, what are all the levels, and what are all the types. Now edge processing. So the meaning edge processing is whenever the data is being collected, all the data will be processed at the source, at the edge. Okay, that is why it is called as edge processing. So imagine you have some sensors, then you will be having some microprocessors and microcontrollers. So all the data which was collected by the sensor will be locally processed by your microprocessor. Okay, so once the process happens, you can have any kind of feedback from the source itself. Okay, all the data which was processed will now be sent to your cloud, you know for recording purposes, but the process happens at the source. Whatever the decision after collecting data happens at the source. For example, you have a smart camera detects motion and then sends only alert instead of full video. So you have a motion sensor that detects motion. Okay, now you have a camera that also records all the motion. So whenever there is a change, whenever your camera records some kind of movement, okay, it will not send all the data to your cloud because it takes a lot of memory storage. So if there is a change in a moment, it will only record as it will give you an alert, there is some kind of movement in your area. And then once you receive those alert, and if you want to see whatever movement happening there, then you can log into your server and then look at it. Okay, so therefore it reduces the amount of data it sends. It will only send you some alert. So next is fog processing, which means data will be collected by using some kind of sensors. It will be sent to a nearby servers. Those servers will process the data instead of your cloud. Okay, intermediate processing will happen here. So for example, you have smart traffic lights, which means based upon your traffic, your lights will change. Let's just say you are at an intersection So in one side of the area, you have a lot of traffic which is congested here. So what it does is, your local processor will process those information. It will take decisions based on those information, such as the path with more traffic should open first. So it has opened, the traffic has been cleared. So what happens? All these things will be recorded and then for a future purpose in your cloud. So initially your camera records the traffic, it sends to a local server. That local server will process the information and then it will give some feedback to your signal. The signal opens, the traffic has been cleared, and then all these process will be sent to your cloud. Okay, so immediate or local servers where the processing happens, not at the source. So next is cloud processing. So basically what is cloud processing is, your data collector will collect information. All the information will be transferred to your cloud. Once your cloud receives all those data, it will process all those data and then further changes happens. Let's just say for an example, you are using a moisture sensor. So if my moisture sensor records some kind of changes in my environment, it will send all the information to my cloud. Once my cloud gets all those information, it will process each and every value. So let's just say you have put a logic in your cloud, which is, if my moisture value gets below 60%, switch on my motor so that the pump will allow water to my field. The moisture in my field goes up. So what happens? Initially data will be collected, it will be sent to your cloud. Cloud will compare a value and then a signal will be sent to your motor. The motor switches on and then your field gets water. So basically a difference between edge processing and your cloud processing is the amount of time it takes to process data. So the latency will have some kind of effect. We'll compare. So in edge processing, you have a processor at the source. Your moisture sensor sends data to your processor. Processor will send immediate response to your motor. Pump has been switched on. The water flows. So what happens? The moisture level goes up. Okay, moisture level goes up. And then what happens? Again, the sensor sends some data. My set value, the moisture level has gone above my set value. So my processor will send a signal again. My pump will be switched off. All these things will happen in real time. Now let's take cloud processing. So initially, in the same example, the moisture sensor will sense some changes in my field. It will send all those data to my cloud. After receiving all the data to the cloud, it will take some kind of decision based upon my logic. So where problem goes on here is, if there is a disruption in your communication, the further application will be stopped because all this data has not reached your cloud. Okay, so if there is an application which requires immediate response or immediate control, you will go for edge computing rather than cloud computing. Okay, thank you. We will look at what are all the protocols which we follow in your IoT in our next topic.